Check out these weightlifters. The one on the right's lifting his weight faster, but they're both doing the same amount of work. The reason I can say that is because work is the amount of energy that's transferred. Or to put it a simpler way, this is the way I like to think about it. Work is equal to the amount of energy you give something or take away from something. Both weightlifters are giving their weights the same amount of gravitational potential energy. They both lift them 2 meters and the masses are 100 kilograms each. Plug those into the formula for gravitational potential energy and you find that the work done by each weightlifter is 1,960 joules. But the weightlifter on the right is lifting his weight faster, and there should be a way to distinguish between what he's doing and what the other slower weightlifter's doing. We can distinguish their actions in physics by talking about power. Power measures the rate at which someone, like these weightlifters, or something like an automobile engine, does work. To be specific, power is defined as the work done divided by the time that it took to do that work. We already said that both weightlifters are doing 1,960 joules of work. The weightlifter on the right takes 1 second to lift his weights, and the weightlifter on the left takes 3 seconds to lift his weights. If we plug those times into the definition of power, we'll find that the power output of the weightlifter on the right during his lift is 1,960 joules per second, and the power output of the weightlifter on the left during his lift is 653 joules per second. A joule per second is named a watt, after the Scottish engineer James Watt, and the watt is abbreviated with a capital W. Alright, let's look at another example. Let's say a 1,000 kilogram car starts from rest and takes 2 seconds to reach a speed of 5 meters per second. We can find the power output by the engine by taking the work done on the car divided by the time it took to do that work. To find the work done on the car, we just need to figure out how much energy was given to the car. In this case, the car was given kinetic energy and it took 2 seconds to give it that kinetic energy. If we plug in the values for the mass and the speed, we find that the engine had a power output of 6,250 watts. So what does power mean? Power is the rate at which work is done.